Okay, so today I am going to solve a problem that I previously solved in the past, and I'm gonna solve it again from scratch and attempt to explain the logic behind the solution as well. So I'm gonna get started. Okay, so this is the problem. It's just called the longest repeating character replacement, um, medium difficulty problem, and the companies that love to ask it. Most recently, Google, Facebook, and Amazon. They have Google has asked it 12 times in the last 6 months. Facebook 8 times. Um, yeah. So okay. So this problem is similar to the one I did previously. It's like the second one I uploaded in the channel. So I'm gonna probably also link to that when I upload this thing to YouTube in the description. Um, the only conceptual difference here is that, well, it's basically that the size of the window is constrained. So let's see what that means. So I'm going to read the problem statement first. You're given a string s and an integer k. You can choose any character of the string and change it to any uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. So we're still dealing here finding a substring, right, within a string that satisfies a condition, right? And then we also have a constraint, which is this integer k, which basically tells us how many times we can perform, um, basically switching a character for another character in the string, right, or in the substring. So we can return the length of the longest substring containing the same character, right? So basically, if we look at this example here, it's always easier to look at the examples the problem gives us. We can exactly see what this means in more detail. So this string a b, and then we have k equals 2, and the expected output is 4, right? Because we can replace two a's, right? These two a's with two b's, right? So then this string will become B, 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 or we can replace the two B's with two A's, right? So here will be A, and then here will be A, and the whole string will be right? And of course, the output is 4 because we will have four A's or four B's, right? And then, well, here we have the constraints as well. So specifically, we will have the minimum amount of characters in the string will be 1, right? And then the maximum characters will be 100,000. Yeah, I believe this is 100,000. So basically, we need an efficient solution to do this, meaning that the solution basically won't pass if we attempt to brute force, do a brute force approach. That means an n squared approach. Okay, so let's get started. So for this one, since we're also searching for a substring, right, an adequate substring, we can still use the sliding window technique that we used to solve a previous problem, similar to this one. So let's do some diagramming at the moment. So I'm gonna take this example here, um, and we're gonna basically walk through the algorithm at a high level, and then we are going to implement it. Okay. Okay, perfect. I'm just gonna copy these guys a few times down here. Okay, so, and I'm also going to put our constraints. Okay, we have it present here. Okay, so let's just walk through kind of the logic first. So let's say in our first substring, we have this A, right? Um, and then in the next substring, we have these two A's, right? Um, and here, it basically won't really matter how we conceptually do the replacement. So, for example, here, this could be replaced by B, right? One time, so this could become a B. And then in the second time, we could also replace this one with B, right? And will not really make a difference. So, and then if we consider the next substring here, the important thing to note is that we can see that we have a in this substring is more frequent than B, right? So we have two A characters. So that's like something important to understand, right? So technically speaking, like if we want if we want to have the substring with most repeating characters, right? That's what we're trying to do. We can change this guy, right? So we can change this guy to be A, right? And then we can do that one time. So this, let's say this substring, because of that, or right, is also valid. Um, so in the next substring, we will have this one, right? I'm just gonna erase this thing here. So in the next substring, we will also have three letters, right? And we can change the B to also be an A, right? So we're swapping one time. So this one will also be a valid substring. Now we have four A's, right? And then if we go to the next window, for example, um, we will have now two B's, right, and three A's. But then we can only do we are constrained to only do that replacement one time. So in this case, this window will not be valid because, for example, if we still have 3A, so they're the most frequent character, right? So for example, here, if we change this one to A, right, and we have here 4A's, we still have um, this B left, right? So then in that case, it will be considered invalid, okay? So that's the basic idea of the algorithm, right? So for example, in terms of returning the length of the longest substring containing the same letter, right? This this substring right here will be the longest one, right? So it will basically contain one, two, three, and four letters, right? So this is going to be the longest substring until now that we found. So we also have to keep track of this, right? So the previous one was one because it had one character, right? Then the previous one was two, right? Then the previous one was three characters, and then the one we just did was four. So we always have to also keep the maximum um, longest substring. So we need to keep count of that through each iteration. Okay. Um, and also we have to basic and then also thing to note here is that we're always trying to expand, so to speak, let's say in terms of the sliding window, the window right to the right, and we're always keeping one side fixed, right? So in this case, we're expanding as much as we can because we have to find, of course, the longest substring. But whenever it's invalid, we basically need to shift the start index of the window to the right because and the reason we're doing that is because we had before the window was invalid, we had, for example, this size here, right? And after we shifted, we grew this window one index to the right. It became invalid. But we know that previously this size was in a valid state. So then that's why we can assume that if we move this start index or shift it to the right, we will have a new valid window, right? So that's the idea. And then we start to basically that way the maxim, yeah, basically trying to find the correct window size, right? Trying to maximize it until we basically reach the end of the array. Okay. So yeah, so that's the basic idea. So the other important thing that we need to keep track of, as we are like counting the frequency of characters, we need to keep basically we need to know, or we need to keep track of how we can detect the frequency. So yeah, so a very common way to do this is to use a hash table or hash map, and depending on the programming language, well, you will have the the respective data structure. So, for example, in Python, this could be done with a dictionary easily. So we will need to keep track of the right. So I do a table um, with the characters of the string, and then also of their frequency, right? Their frequency count. Okay, so we can basically. I'm gonna delete all of this, and I'm gonna walk through different iterations of the algorithm. So here we have two characters, right? We have A here, and then we have B, right? Okay, and then we have to initialize two, basically two pointers. So we're gonna initialize um, a start pointer here, right? And then an end pointer here. And then we're gonna start to iterate through the string, okay? So in the first iteration, we will have this one, right? This A, and then we can just put here a update this frequency, so A is appears one time, right? And then in the next iteration, I'm gonna jump here, right? We still have our end pointer now is here, right? Because we're basically sliding it. So this end pointer will determine basically the length of the window, right? And the length of the window also equals the same length of the substring. So that's very important to note. Okay. And then A here becomes two, right? So A appears two times, right? Um, so so let's think about this for a moment as well. We also need a way to determine when the window is invalid, right? So the first thing we need to think about is how to determine our window size, right? So our window size, I'm just gonna label it as WS, equals the end index, right? So the end index plus one. I'm gonna go into a moment why I'm adding plus one, but I think it can also be done in a different way. But let's try later when we're finishing the problem as well with the unit test cases, and then we're gonna basically subtract the start pointer. That's the window size, right? So for example, if we go here, just with the first one as an example, the endpoint is zero, right? And we say plus one, right? And minus zero because the start index is at zero at the moment. And this basically would equal one, right? Which is true for this because our window size is one and it's containing one character, right? But then we also need to determine the condition for the window validity, right? So and that is given by this this operation, which again restricts the number of character exchange we can do in the substring, right? But since we are always trying to take a look at which one is the most frequent character, right? Because for example, again, like if we have if we have this window here, the most frequent character is A, right? So naturally, like if we swap B for an A, well, here we will get four characters in this substring, right? So we always need to look at which character is the most frequent one, right? So we can replace the remaining character with that A only once, right? That's basically our constraint. The good thing is that we don't really have to do a literal replacement. So, and we will see that in a moment. Why? So just because of that, we can say that the validity, right? The validity is equal to the window size, right? Window size minus the most frequent character in the current, in our substring. And at the same time, we have to ensure that this is um, smaller than or equal to k, right? So that's basically gonna be our rule. Okay. So I'm gonna erase this here, and then we're gonna yeah, basically keep keep expanding or growing our substring, or so to speak, let's say the window, until this condition is false. Okay. So I mean, for example, here, if we want to just do this quickly, so for example, here, maybe it will be quicker to type it actually. Let me see. Uh, Normal. So for example, in this case, WS, it's going to be 1 plus 1 minus 0, right? So that's going to be 2. And we're going to have the validity is going to be 2 minus, and then of course the most frequent character is 2, right? And then this is going to be 0, and 0 is smaller than 1, right? So this is it's still going to be a valid window, right? So let's also like keep track here of the longest one. So for example, here in the first one, longest is 1, and this one it will be 2, right? So I'm gonna put this guy here. Maybe we can, yeah, let's make it smaller. So now let's go to the next iteration. So now we're gonna have these characters here, right? So our start pointer is still gonna be here, and then our end pointer is gonna be here. So now it's gonna be 2. Our end pointer is gonna be 2 plus 1. It's 3 minus 0, 3. And then we're gonna have window size, and then still our most frequent character is A, which is it appears twice. So this is 1, right? So then our window is still valid. One thing we also need to do is update here to 1. Right now we have B appears 1 time, so it's still valid, of course. And we can also verify this graphically, because if we swap this for an A, right, 1 time, we can do this operation still. We have 3 A's in this substring, right? Okay, cool. So then after that, we update this length counter, right? So it's gonna become 3, and now we're gonna go to the next one, right? So now it's gonna be contain this one, and then our start point is here, or our start pointer, and then our end pointer is now, of course, here, because we're increment that end pointer by 1 in every iteration. Oops. And then we can do the same calculation. So our end pointer here is 3. So now here we have 4. Our window size is 4, right? 4 characters. Um, and then now, of course, A changed this frequency, so we need to update it here. This is now 3. So this three A's, right? So 4 minus 3, and it's still 1. So this window is still valid. We can also clearly see it here. If we change this B for an A, right? This B for an A, we still get it's 1 replacement, so it's still valid. So here we will update this counter to 4, right? And then we're gonna keep expanding that window, keep expanding it until here. And then here is our start, and then our end. And then we basically perform the same operation, right? Again, so this one will be 4. This one will be, the window size is now 5. And then on now 2, B is now appearing twice, right? Twice. And A is still our most frequent character, right? So now is still 3. So 5 minus 3 is 2. So now the window is not valid, right? Because now we need to perform at most, 2 operations to so we can do this replacement accordingly, right? So what does that mean? I mean, we can see it here. So we need to replace 2 B's in order to get basically this substring be full of A's, right? So here we can see it graphically, and we can see it here in this formula here, right? Or well, it's not, yeah, we can call it a formula, but this basic mathematical expression. Well, actually, mathematical formulas can also be simple, right? Okay, so this will need to change one time to A, and the other another time to A, so we can have these 5 A's. Okay, but then of course we have to do that operation twice, and we have this constraint here. So just because of that, we will have an invalid window, right? So actually, this window we can basically just color it red because it's invalid, right? It's an invalid window. So now what happens when a window is invalid? Uh, this basically following a little bit also like always the same pattern in the sliding window algorithms is that we need to basically shrink the window, right? Until we find or until the condition is valid. So basically what that means is the following. The start pointer, right, is no longer at index 0, and we have to shift it 1 to the right, okay? And of course, in this instance here, this end pointer will remain here, right? And now that means that the window or the substring now will be this, right? And because we're doing this, we also need to update this frequency table, right? So now in this substring, there's only 2 A's, right? Not 3. So then we need to subtract that, and this will become 2 again, right? And now this is a valid window, and now we keep doing the same operation over and over, right? So then the next iteration, we will expand the window and then do the check. And if it's invalid, we will shrink, we will keep shrinking the window and so on and so forth, right? Until we reach the end of the string, and of course our iteration has to stop, okay? So that's basically the idea of this solution, and it's quite simple to implement, and let's say conceptually to understand it. Also, in my opinion, I think it makes a lot of sense. So let's start to implement it. Okay. So first thing we need to do is to have our start pointer, initialize it to 0. And then we also need to keep track of the longest substring. So let's say longest substring. We're going to have the counter set to 0. And then we're going to start to iterate through the string. Okay, I'm retaking this video because it got cut off. The previous one was taking too long. So let's continue the problem. So now we're going to iterate through the string. Let's rename this to the end pointer. So now we're going to add the characters to the frequency map. So let's make that char character map. So we're going to go here, so string, the current character, and pointer. So we are going to get this character here, and it doesn't make 6, we add 1, and we add +1. So basically here, if this is our, for example, our input string, A is going to be the first character, right? So then after this line, A is going to be set to 1 here. And then we need to get the max frequency count. Max frequency, and this will be, we're going to use the max Python's max operator. Oops. To return the maximum between the current max frequency and the maximum frequency at the current character. So it's going to be like this. Kind of annoying syntax here. And end pointer, right? So basically what this will do is we, for example, here, the max frequency is 1, right? And the max frequency here, well, okay, oops, it will be, of course, not defined. So we need to set this here. Oh my God, I added the submission by mistake. Yeah. Okay, so I added it here. So then this will be 1, this is 0. So the max frequency is still 0, of course. Sorry, 1, right? Because it's updated. So then this will be 1 in the first run. And then we need to calculate the window size, which, as we saw previously, it's the end pointer plus 1 minus the start pointer. So this, of course, will be 1 because 0 plus 1 is 1 minus 0 is 1. And then we need to basically do our validity check. So if the window is invalid, we will basically shrink the window. Shrink the window until it's valid. Okay, until it's valid again. So as we saw previously, we have the window size minus the max frequency. So this has to be smaller or equal to k, right? But since we're gonna do this, if the window is invalid, we have to say if it's larger than k, because while the window is invalid, we're gonna basically shrink it until it's valid. So for that, we will need to decrease the current frequency, the frequency of the current character, right? That corresponds, that it's in the map. So we will say s, well, not the current character, sorry, at the start pointer. So if we go here, for example, when it was invalid, the A needed to be decreased, of course, to the new window, because the new window is going to become this one in this case, for example, when we shift the start pointer. So then we need to decrement the frequency of where the A is encountered. So for example, here it was 3, but once we shift the window here or we shrink it, the frequency should be 2, as we see it here, 1A and 2 A's, right? So we need to subtract 1 from there. The other thing we need to do is move our pointer by 1 to the right. And that's it. And then after that, we need to calculate, right? Keep track of this L, right? In this case, which is basically the longest substring. We'll just say count, so it's kind of like clear. Longest substring count. Again, we're going to use a max operator in Python. and we're gonna do it between the window size and the current longest substring count. So remember that the window size determines or is equal to um, the substring, right? So for example, here we we always saw that the window size always corresponds to the number of characters in in the substring, or and then another way to say it, the window size corresponds to the size of the current substring that we're looking at. Okay, so for example, in the first iteration, of course, the window size will be one. One is larger than zero, so the longest substring count will be one in this case, and we will continue to do this and to update this value. And then at the end, we of course have to return this thing here, and that should be it. So this algorithm is basically it's the expression in code of what we walk through here. So let's run this and see if it passes. Okay, I'm missing a parenthesis here. Oh, okay, sorry, not I was missing a closing bracket. Okay, cool. So let's run it again. Okay, so there is a mistake somewhere. So the output, I'm saying the output is one. Oops, and I'm saying the output is one here too. Max frequency. Okay. Some live debugging here. Okay. I think I see. I see. Yeah, what has happened is that I forgot to actually redo this calculation here because we need to update the window size, right? Because we have updated here the start point, right? So then we need to update the window size. So it uses the most up-to-date window size or the new window size. So let's run the code again. Okay, still wrong answer. Output is still one. Mm, that is weird. Okay. Hmm. Okay, I'm gonna try to do something. I mean, this should be a more optimal way than this. So char map dot values. Let's see. Okay, it's still one. Okay, then it's not here. Let me just move here. It is. No. What is it? Oh my god. Shit. It's because I forgot to do this. Um, yeah. Oh my God. What a stupid thing. Jesus Christ. Okay. So let's remove this because this is not optimal. We'll just continue with this one. Yeah. Oh my God. How embarrassing. But I'm not gonna edit this out because that's the whole point of doing this. Sometimes things happen in life. Things are not perfect, so we need to embrace it. Okay. Cool. So this is it. This is the solution. So I'm just gonna do some random test cases. So B, C, C, A, N, M, F, 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 I, P, 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 P. And let's say K is equal to, I don't know, 2 or 3 perhaps. Let's run it. And yes, okay, cool. our algorithm performs as expected. So yeah, I mean, this is the solution of the problem. So let's submit the code. I'm just gonna, yeah, just erase these guys here. So let's submit it, make sure everything is passed. Okay, cool. Yeah, awesome. It's passed. Okay, cool. Just one thing as a recap. I'm just gonna do some pseudocode. So basically, if you guys see the previous video that we also do deal with a similar problem. Um, so the main pattern, so the right that we can recognize with these types of problems is that we have a for loop, right? For loop, iterating input, right? And then below it we have basically some action, or let's say some logic, and then after that we have our while loop, right? So while window is invalid, we basically we shrink it, right? So we shrink the window, okay, and then here we basically also do some logic, right? So that is basically the pattern of this technique. We iterate through the input. We shrink the window while the window is invalid, right? And then after that, we always do some other logic here at the bottom, right? So currently, what we have done is basically we have to count. So we have to keep count of something. So this would be done here, obviously. So that's the basic pattern of this. Yeah, so that's it for now.